Hi everyone, my name is Hassan and in this video we are going to talk about queue-based load leveling pattern. This pattern comes under many categories of cloud design patterns. First and foremost, messaging category. And this is very obvious because we are talking about message queues and the messaging category is going to be at the top of our list. Also, this pattern adds a lot of reliability and resiliency and performance enhancement to your solution, as we are going to see in more details in this video. And this pattern simply uses a queue to work as a buffer between the source or the producer and the consumer or destination. And we are going to see this in more details in a minute. It's always good to mention other related patterns to the queue-based load leveling pattern. The related patterns are competing consumer pattern and throttling pattern. Hopefully we are going to make a video about these two patterns in future. Now let's dive into the example to help us understand this pattern better. Let's assume that we have our users and we have our service. It could be a website hosted in Azure App Service, it could be an API hosted in API management, it could be Azure Functions app, anything you could think of. And then the users are going to interact with our service. Then we are going to have at the backend a SQL database engine that our service needs to interact with to perform different sort of read and write operations. So far, everything is perfect for our solution. Our SQL database is able to handle the read and write operations being sent by our service, and our service or website or API is able to handle all requests being sent by the external users. So we don't have any problems at the moment. Then over time, our service or website become more popular and more users are started to interact with our service, sending more requests to our service, which is going to lead to an increased number of read and write operations that our service need to perform on the database side. And of course, our database engine hasn't been designed to handle this increase of the workload we are experiencing at the moment. And sooner or later, it's going to impact the performance between our service and the database engine. Now, there are few things we can do at the database level to help us mitigate this problem. I'm going to touch on them really quickly before we get back on track to our pattern. So what we can do at the database level is to scale it up to the higher tier, or maybe highest tier, which is going to assign more CPU and memory to our database instance, which is going to help it to handle this increased number of requests we are getting from our users. This could be one approach. Another approach, we could have one or more read replicas. So we are going to direct all of the read operations to the read replica databases instead of the primary database. And we do this to offload the read load from the primary database to free it up to perform the write operations, which is more resource intensive than the read operations. So these are the two approaches we could do quickly at the database side. Let's assume that we have gone with the upscaling our database engine to the highest tier and we still have this problem. We still experience some performance or deadlocks or errors happening between our service and our SQL database. And in a way or another, it's going to be propagated to the end user while they are interacting with our service. And they will experience that their requests are not being executed on our website. This is why this pattern is listed under reliability and resiliency, because it could save your solution from being unavailable to external users or from being down or suffer performance issues. Now, after we have talked about the problem, let's see how can we use this pattern to solve this problem. But first of all, let's clean this up. And instead of having a direct interaction between our service and the database engine, we are going to introduce a message queue. It could be Azure Service Bus Queue, for example. And then our service is going to send the database operations or requests in the messages, in the message queue. And then from the other side, we are going to have an Azure Functions app that listens to the message queue and is going to be triggered for every message being placed in the message queue. And then the Azure Functions app is going to pull messages from the queue and execute it in the SQL database. And by doing this, we are buffering the database operations between our service and the database engine to be executed at a slower pace that the database engine can handle. And more importantly, it wouldn't affect the user experience while they are interacting with our service. Because the request has been already sent, when a service is placing a message in the message queue, the request has been already sent and the user operation has been fulfilled, in a way or another. Yes, it hasn't hit the database yet, but it's in the way through. Now let's consider that we are an e-commerce application, like Amazon for example, and you are a registered user and Amazon knows your delivery address and your credit card and everything about you. When you place an online order, it's not a time-critical operation that requires to hit the database in a real-time fashion. And I'm going to tell you a personal experience for myself while I was shopping at Amazon.com. Many times after I place an order, after I successfully place an order, I got an email back after a few minutes or seconds that tells me that my credit card might be expired or certain item is not available anymore in the warehouse. Then I can go back and put a valid credit card number or select another item that's still available in the warehouse. And what this tells you that order placement operation is not a real-time operation at Amazon.com because it's not a time-critical operation. It would perfectly be suitable to be implemented using queue-based load leveling pattern without any problems. Now let's move to another scenario. Assume that we are in a banking application and you want to perform a cash withdrawal operation. And it can be very tricky because you cannot queue cash withdrawal requests in a message queue while the actual balance hasn't been changed in the SQL database yet. You might end up that the client may be performing more than one cash withdrawal operation based on a smaller amount of balance that they have in the database. And you need to be very careful when you use this pattern with this kind of scenarios. And actually we are going to have it in more details to help you understand it better. Let's assume that the client is sending a cash withdrawal request by 100. And the client balance in the database is $100 as well, which would suggest that the cash withdrawal operation will be fulfilled successfully. Now, let's assume that our service has taken this request and put it in a message queue, and for some reason the message hasn't executed yet in the database and still stuck in the queue. Maybe because the database engine is busy performing other operations. Alright, now the same user sent another cash withdrawal request by $50. If our service is going to check the client balance in the database only, it's going to be a problem. Because by checking the balance in the database only, it's going to tell that yes, this user can perform a cash withdrawal with $50 because they already have $100 balance in their account. And it neglects the fact that there is another cash withdrawal operation still stuck in the queue by $100, which if we take it into account, it wouldn't make the new cash withdrawal by $50 to be accepted. So, what we can do in this situation is, while our service is checking the client balance in the database, also, our service needs to take into consideration the other cash withdrawal requests that may stuck in the queue, and consolidate both together and send back the actual client balance that they actually have. And if this happens, our service is going to tell the client that they cannot perform cash withdrawal with $50 anymore because they don't have enough balance in their account. This is what I meant that you need to be very careful when you use this pattern, and you need to be aware of what kind of scenarios you are using this pattern for. And for the read operations, you need to have a very strong reason to use this pattern for the read operations. Actually, I couldn't think of any at the moment. I think it will be way more efficient to direct the read operations to read replica databases instead of buffering them in a message queue. Hopefully this is now clear for you. Now let's talk about some considerations you need to keep in mind when you use this pattern. Let's assume that your service has decided to put 1 million messages in a message queue, and this in return is going to trigger or fire 1 million executions of the Azure Functions app to execute these messages against your SQL database. And both of us know that the SQL database won't be happy about that. So you need to avoid overwhelming your target or destination with too many requests, even though you're using this pattern. So you need to specify the rate at which you are going to execute these requests against your destination. Also, you need to be aware of that message queues are one-way communication. It won't be suitable to send an acknowledgement message back. If you want to send an acknowledge message back, you need to implement other patterns, like request response pattern. Also, you need to be careful about auto-scaling the services behind the message queue, which is going to be the Azure Functions app in our example. You don't want to have many competing services competing for the same message. Or also, you don't want to confuse the message queue, which Azure function instance it should trigger when it receives a certain message. It might do more harm than good. Now let's see when you should use this pattern when your application is going to expect a heavy workloads that your backend database cannot handle, and you need to buffer them somewhere so you can execute these requests at a rate that the database engine can handle. And when you shouldn't use this pattern if you are expecting a real-time response from the target. As I said before, it doesn't make any sense to use this pattern for read operations because you are expecting data to be returned straight away. Now we are coming to the end of this video. I hope now it's clear for you what this pattern is about. What are the challenges it tries to solve? How you can use this pattern to improve the resiliency and reliability of your solution? How you can use the message queue to buffer requests between the source and destination? When you should use this pattern and when you shouldn't. I hope you enjoyed this video. If you have any questions, please put it in the comments below, and thanks for watching.